Okay, I'm going to make a few quick comments on the board picture. Here we're finding f of g of x, where g of x is the extended basic reciprocal function, f of x is the extended basic exponential function. G of x is defined on the interval -2, -1/2, union 1/2, 2. So only numbers in this interval can go into f of g of x, okay? Because otherwise they won't go into g of x, okay, if they're not in that interval. There could be other restrictions due to the nature of f, but that's not the case here. So we can picture the domain of g of x as this interval union with this interval. The range of g of x is the set of y values you get for x values in this interval. Well, here are the set, here is the curve for those values, and the range is the set of outputs. These are the inputs. Outputs are here and here. So the outputs consist of the interval -1/2, 1, 1/2, 2, and -2, -1/2. And those go into the function f of x. So domain of g of x is this. Domain of f of x is the interval from -2 to 2. Every one of the numbers in the domain of g of x will go into f of x. So here's a picture of f of x. Here are the numbers that are output by g of x. That's this interval now becomes an input to f of x. This y interval is also an input to f of x. And g of x outputs numbers here and here. And f of x then will act on those numbers and output numbers from here up to here and from here up to here. Every number that comes out of g of x works in f of x. Now that's not the case if we do the same functions, except g of x is now the reciprocal square function, because the reciprocal square function outputs numbers between 1/4 and 4. Now its domain is the same as the domain of the reciprocal function, so the domain of f of g of x is a subset of that, but you can't include, excuse me a second, I thought I'd sent this. I don't know why I didn't send. It's a link to my next class, which is starting in like 9 minutes. Okay, sorry. So I lost my sentence, but I'll kind of repeat. The domain of f of g of x can't include numbers that aren't in the domain of g of x, because the first thing you do with a number is you do x. You do g of x. So the domain of f of g of x is always a subset of the domain of g of x. And the domain can't include values of x that give you g of x values that are not in the domain of f of x. And that's a problem. That's a restriction here on the domain of f of g of x. Because the range of g of x is 1/4, 4, but not all those numbers will work in f of x, whose domain is only from -2 to 2. So g of x puts out values from 1/4 to 4. Here's kind of a picture, just a small picture of g of x, all the values that it outputs. They start at 1/4, they go all the way up to 4, as you know if you're familiar with this function. And you should be very familiar with this function and the other basic functions. Then the values from 1/4 to 4 don't all work in f of x, because the domain of f of x only goes up to 2. So you want to put the numbers from 1/4 to 4 in, and you can do that with the complete exponential function, complete basic exponential function. But you can't do it with the extended basic exponential function. So that restricts what you can do. So that the only x values that you can use are those that output numbers between 1/4 and 2, so that those numbers become the inputs to the f of x function. And we don't have a way other than a calculator, which we're not going to use, but by estimating the value of x that gives you g of x equals 2, the biggest number we can put into f of x, we determine that the approximate interval here goes from 0.7 to 2, and we conclude that that's the domain of g of x. Now the range of g of x, which we didn't talk about in class, consists of all the numbers we get from this part of the curve. And that would be all the numbers from about 1.2 up to 4. So I can say the range of f of g of x is about 1.24.